Hi, this is the CAD/CAM Lessons channel. In this video, I will give you a short and quick introduction to FreeCAD for complete beginners. We'll create a very simple part so that after watching this tutorial, you will have made a basic 3D model and be able to create a similar one on your own. We'll use only the most basic operations for creating 3D solids and simple shapes. My goal is to make sure that anyone just starting with 3D modeling can create basic models after completing this tutorial. I won't go into too much detail about FreeCAD itself. This video is meant to show you just the essential tools for building simple parts. If you don't have FreeCAD yet, you'll need to download it. To do this, go to the official website freecad.org, then click the Download Now button and download the version for your operating system. As you can see, FreeCAD works on various systems. I use FreeCAD both on Windows and Mac. I'm currently recording this tutorial on a Mac, but if you are using Windows, you'll notice that FreeCAD looks and works almost the same. And that's one of the FreeCAD's big advantages. You can use it across different operating systems, which is great whether you are collaborating with others or just working on different computers. Once you've learned FreeCAD, you can easily switch operating systems without losing your skills. Everything you've learned still applies. Go ahead and download and install FreeCAD. The installation process is standard and usually doesn't cause any issues. If you do run into problems, they are usually related to your operating system, not FreeCAD itself. If you are having trouble installing FreeCAD, go to the discussion forum and post a question there. As I said, in most cases, these are operating system related issues. The installation generally goes smoothly, and if anything comes up, the best place to get help is the FreeCAD forum. Okay, let's launch FreeCAD. It will start with the first startup setup, which looks like this. Here you can set the language, unit system, and navigation style. These are the settings I use, and you can choose similar ones if you like. As for themes, there are two main options, light and dark, but there is also a third option, the classic theme, which can be selected in the preferences. Let's open the preferences to set the classic theme. If you are on Windows, open the edit menu and choose preferences. And if you are on a Mac, click FreeCAD in the menu bar. It may not be visible in this recording. Then select preferences. And here choose the FreeCAD classic theme. This is the theme I use, and if you want FreeCAD to look similar to what you see in this tutorial, you can use this one too. And let me mention something right away. The appearance of FreeCAD might differ slightly on your computer. Some toolbar icons may be in different places, but that's not a problem. You can freely customize the position of toolbars. If your icons are in different locations, that doesn't mean FreeCAD is broken, it just means the toolbar layout is flexible and you can arrange it the way you like. We'll come back to that in a moment. Another important thing about FreeCAD is that it has a modular structure. This means that commands are grouped into modules. For example, when we are designing a 3D model, we don't need commands related to generating CNC machining programs. So those commands are hidden and don't clutter the workspace. And while working in the 3D modeling module, you only see the tools relevant to modeling. This helps reduce visual overload and keeps things organized, which becomes a big advantage as you work on more complex projects. FreeCAD is a parametric 3D CAD system. This means we build 3D models using features and parameters, and every action is recorded in the model history. Each step in the modeling process is saved, and at any time you can go back to an earlier step and make changes. This is a major benefit of using FreeCAD. For example, if you finish designing a part and realize later that you need to change a dimension, say increase a hole diameter from 10 mm to 12 mm, you don't have to redesign the entire model. You just change the relevant parameter and the model updates automatically. This approach is especially helpful for advanced users or 3D printing enthusiasts. If you print a part and it doesn't fit quite right, you can easily tweak a few parameters without having to start from scratch. As you can see, FreeCAD had a lot of advantages, and I believe it's a great tool for beginners. You might come across different opinions about FreeCAD, some of them negative, but many of those opinions are based on older versions of the software. Since version 1.0, a lot of major issues have been fixed, and FreeCAD now works much better. So don't rely too much on what others say. Follow this tutorial and decide whether FreeCADs work for you. Okay, to start creating a 3D model, we go to the Part Design Workbench. In this workbench, we begin by creating a new project. Here you can see a list of available workbenches, and by default, Part Design should be selected. And to start working, make sure this workbench is active and click the new icon to start a new project, or you can click the parametric part button. And now we've entered the Part Design Workbench. Here we have the access to the tools available in this workbench. You'll also find a drop-down menu, Part Design drop-down menu, that gives access to the same commands, and some of them are also available as toolbar icons. If your icons are arranged differently, you'll see 4 small dots here, and you can use those to drag and reposition the toolbars. If any icons are missing, just right-click on the toolbar area. You'll see a list of toolbar groups, and you can toggle them on or off. In the part design module, we build parts based on 2D sketches. That means we first draw flat geometry and then apply 3D features to turn those sketches into solids. And to create a sketch, click the Create Sketch command. Then choose a sketch plane. We can select from the basic coordinate planes. If we want to draw a sketch as if we were looking from above, we select the XY plane. Now we've switched to the Sketcher workbench and we can use its tools. This is another great feature of FreeCAD. In Part Design Workbench, sketch tools don't get in the way when we don't need them, but once we start sketching, FreeCAD switches to Sketcher automatically. In the Sketcher Workbench, we have tools for creating simple basic geometry, and let's start by drawing a rectangle so that its center lies at the origin of the coordinate system. We'll use the Center at Rectangle tool. If you expand the rectangle options, you'll find this specific command. Select this command, and to place the center of the rectangle at the origin, just hover over the center point of the coordinate system, and when it highlights, click the left mouse button. Now, while drawing the rectangle, we can enter its dimensions, and let's set it to 80. Hit enter, by 30, and hit enter. The rectangle is now created, and now let's draw 2 circles. Select the Circle tool and draw the first circle so that its center lies on the x-axis. When the x-axis is highlighted, click the left mouse button, and now define the diameter of this circle, type 10 and press enter. The circle drawing tool is still active, so now draw the second circle. Click here to place it, and this time don't worry about its position and size, and right click to cancel the circle drawing command. At this point, the first circle has a defined diameter and is partially constrained. We can still move it left and right along the x-axis. The second circle has no defined diameter and no defined position. To define dimensions and relationships between shapes, we use constraints, and let's make these two circles the same size. Click on both circles using the left mouse button to select them, and then apply the equality constraint. This makes their diameters equal, and now if you change the diameter of one circle, the other will update as well. And to change a dimension, just double click the dimension value with the left mouse button and enter a new value. Now let's define the position of the second circle. I want its center point to lie on the x-axis. To do this, select the center point of the circle, then select the x-axis and apply the coincident constraint. This sets a relationship that forces the point to line exactly on this axis. Okay, I will undo this by pressing Ctrl+Z, and I'll show you another way to set position of this circle. We will use a symmetry constraint that places this circle symmetrically to this circle relative to the y-axis. To do this, select this point, and select the axis of symmetry, and select symmetry constraint. And now these circles are placed symmetrically relative to y-axis. When I change the position of one circle, the position of other circle adjusts. Okay, here we still have 1 degree of freedom, which means something can still move freely, and in this case we can still move the circles along the x-axis, and to lock this down we'll define the distance between the centers of two circles. Click the center point of the first circle, then the center point of the second circle, and apply a distance between these points. To do this, select the dimension command, and here as you can see we have dimension. Click the left mouse button and enter, for example, 50 millimeters, and click OK. Now take a look, the sketch has changed color to green, which means it's fully constrained, and this means we can no longer accidentally change this shape, size or position of any geometry. The rectangle position and dimensions are fixed, the circle's diameters and positions are fixed as well. This is exactly what we aim for when working with sketches in 3D CAD systems. Now let's close the sketch and turn it into a solid. We'll do that by using an extrusion operation. This is one of the most basic methods for creating 3D solids in 3D CAD software. In FreeCAD, this operation is called pad. Click the pad icon. And as you can see in the preview, a 3D solid has been created by extruding our 2D sketch by 10 millimeters. You can change the extrusion length here. This value controls the height of the solid, and let's set it to 5 millimeters. After entering the new value, click anywhere outside the field to update the view, then click OK to confirm. And now we've created a simple 3D solid, and in FreeCAD we can build models in stages, so now we can add another feature to this solid, and to do that we'll create a new sketch And in addition to the main coordinate system planes, you can also create sketches directly on the faces of your solid. And to do this, just click the face where you want to place the sketch and then click the Create Sketch button. But before we do that, let's briefly go over navigation in FreeCAD. Earlier, we selected a navigation style. I'm using the Blender style. And if you hover your cursor over this area and wait a moment, a tooltip will appear showing how navigation works in this mode. And by pressing the mouse wheel, rotates the view, holding the left and right mouse button together pans the view, and scrolling the mouse wheel zooms in and out. And that's all you need for basic navigation in FreeCAD. And now let's select that face and click Create Sketch. And we're ready to create the next part of the solid. We'll draw another rectangle, select the rectangle tool and place the center of the rectangle on this point. And for the first dimension, I want to enter 20 millimeters, so I type 20 and press enter. And for the second dimension, I want one corner of the rectangle to lie on the edge of the existing solid. I could enter a fixed value here, for example 30 millimeters, but instead I'll show you a different method. For now, just click anywhere to finish the rectangle without defining the second dimension. Then right-click to cancel the command. And now you'll notice there is still 1 degree of freedom. That's because we can still change the second dimension. And what I want is for that corner of the rectangle to lie exactly on the edge of the solid. At this moment, I can't place that corner directly on the edge of the solid, and to constrain the sketch to the edge, we need to create reference geometry based on the solid. We can do this using the Create External Geometry tool. Click this tool, then click on the edge you want to reference. A magenta line appears. That's the reference geometry linked to the existing solid. Now right-click to cancel the command, and to place the corner of the rectangle on this reference line, select the corner point, then select the line and apply the coincident constraint. This tells FreeCAD that the point should lie exactly on the line. Click Close to finish the sketch, and now, based on this new sketch, we'll add another feature to the model. We'll do that using the Path tool again. Set the length of extrusion to 10 millimeters and click OK. This adds a new section to the solid. If you want to remove material based on a sketch, you can do that too. This time we'll create a sketch on one of the solid's faces. Select the face and click Create Sketch. Now let's draw a circle. Select the Circle tool and place the center of the circle on the y-axis. Simply move your mouse over the y-axis until it highlights, then click the left mouse button, and for the diameter enter 10 and press enter. Right-click to cancel the command. At this point, the position of the circle is not fully constrained. You can still move it along the y-axis. I want to place the center of the circle on the top edge of the solid. And to do this, we'll again use the Create External Geometry tool. Click the tool and select the top edge and right-click to cancel. Now select the center of the circle, then select the reference line and apply coincident constraint. This ties the center point to the reference edge. Click Close to finish the sketch. And now, based on this sketch, we'll remove material using the Pocket tool. Select the Pocket tool and define the depth of the pocket. You can enter a specific value or choose one of the available options like through all. Select through all so that the cut goes completely through the solid. Click OK, and now we've successfully created a pocket. Next, let's look at some basic finishing operations. We can add chamfers and fillets to selected edges of the solid. To do that, we first select the edges we want to modify. In the 3D view, hold down the Control key and click each edge you want to include. Let's start with chamfers. Select two edges, then click the chamfer tool. Enter the chamfer size, for example 5, and click OK to apply it. Again, with Ctrl held down, select the edges you want to round, then select fillet tool, enter the radius value, and click OK or hit enter. And as you can see, with just a few simple steps, we've created a complete 3D model with both added and removed features as well as finishing details. As I mentioned at the beginning, FreeCAD is a parametric 3D CAD system based on operation history. This means that at every stage of modeling, you can go back to a previous step and edit its parameters. Let's try that now. We'll go back to the first operation, the one where we created the base shape using a sketch and the path tool. At the moment, the sketch isn't visible, but it's part of the first operation. If you expand the tree in the Model tab, you'll see the first path and click the little arrow to expand it, and you'll see the sketch inside. To edit the sketch, double-click it with the left mouse button or right-click and choose Edit Sketch. And let's change the rectangle's width from 80 to 120. Okay. To do that, double-click the dimension and type the new value. And here, for example, let's enter 70 millimeters. OK, click Close, and the model updates automatically. If you also want to change the extrusion length, double-click the path operation in the tree and enter a new length, for example 10 millimeters, and click OK. And the model updates again. You can also rename operations in the model history to keep things organized, and to do this, right-click an operation in the tree and choose Rename and enter a new name. This can be very useful when working on more complex models. If you want to change the color of the solid, right-click on the body and choose Appearance or Set Random Color. In the Appearance window, you can either choose a specific material, or you can manually select a color, and let's pick a material, for example, select stone and close it, and now the solid has a new color. And to save your project, go to the File menu and choose Save As, and then enter a file name and choose the location. And if you want to 3D print your model, you'll need to export it to a format supported by your slicer software. Many slicers support the step format, so I recommend exporting to that. To export your model, select the object you want to export, select entire body, it must be highlighted, go to the File menu and select Export. Enter the name and choose the destination folder, and from the File type list, select step, and as I mentioned, the step format should be better because this format saves the object as a solid, not a mesh of triangles like STL does. This gives you more flexibility later. You can open the file in FreeCAD or another 3D CAD system and still make changes. Keep in mind that exporting to step doesn't include the operation history, but the solid itself can still be edited in meaningful ways. And to export file, click Save button, and here you can set the export setting. You can set the default values, but pay attention to the units and click OK. And OK, we'll stop here, and in this simple example I wanted to give you a quick introduction to working with FreeCAD. Thanks for watching and please subscribe to this channel.